8th grade, you guys are working on 2.4 warm-ups. I'm going to check right now. 2.4 warm-ups. Oh, congruent figures. This is an easy lesson. You guys will like this one.
Okay.
Congruent figures. All right, so your warm-ups. Shh. I did not. Yeah, I don't like rotations. Are not as easy. The key to rotations is you can't rush the lesson. If you rush the lesson, you're going to get confused really quickly. No rushing. This is not difficult stuff. You guys got this. All right, so do your 2 warm-ups, and then go to your key ideas. You have several key ideas and vocab words, so I'll give you just a few moments to do that. Okay, so let's do this warm-up together, because you guys need to know how to do this, not just guess. All right, so what is our first step here, Josh?
Distribute.
Yes, so we're going to do the 1/4 times the 16 and the 1/4 times the negative 20. What's 1/4 of 16?
4x.
Yep, and what's 1/4 of negative 20?
5.
Negative 5. Okay, so then I'm left with 8x minus 5. Okay, and then we need to move things so they're all on the same side. Josh?
You would add 5 to both sides.
Add 5 over here. Okay, so that means I'm going to move the 8x over there, so subtract 8x. I do it all in one step. You don't have to, but I do. So then I get, what's 4x minus 8x?
Negative 4x.
Negative 4x equals 0. Okay, and then x by itself, I divide by negative 4. X equals, what's 0 divided by negative 4?
0.
Okay, so how many solutions does this give you? 1. Because I came up with x equaling a number. Yes, it's 0, but that's still an answer. Okay, so that's why when you go back over here, oh, I need to be back on 8th grade. Would help if I go to 8th grade first. I can hear you talking. Shh. So then when I go back over here, I can say, well, there's one solution.
Yeah.
Okay? Now on this one, we're going to do it again, because I don't put this in your journals. Too much guessing. If you did it the first time, you don't have to write it in your journal. All right, so on this one, we have, shh. You guys are about to be moved. You two are the two I have to silence the most, and you two. All right, so we have negative 1/3, 15x. Okay. You're going to start learning where the respect line is. Okay, so, again, what are we going to do here first?
Distribute.
Okay, so I'm going to distribute this negative 1/3 here and here. What is 1/3 of 15?
Oh, 5.
Negative 5. Very good. What is 1/3 of negative 6? Positive, because this is a negative and a negative. 6 divided by 3 is 2. Yeah, because a negative times a negative is a positive. Okay, 2 minus 4x. Okay, so now I'm going to add 4x over to that side. Ooh, that 4 looks funky. Writing with a mouse is a challenge. Minus, that's a 2. Minus 2. So what is negative 5 plus 4? Negative x. Negative 1x, same thing. 2 minus 2 would be divide by negative 1. Divide by negative 1. So I get x equals, what's that? One solution, many solutions, or infinitely? One solution. So you have one solution twice. When is it infinitely many solutions?
They both equal the same thing.
Yeah, when you get a number equals a number. Any number. 0 equals 0, 6 equals 6, negative 2 equals negative 2. Okay, that means it's infinitely many solutions. If I come out with 7 equals 42, what's that one? Does 7 equal 42? There's no x here. So this is no. So then this is your no solution. Whenever you come out with a number equaling a number that can't possibly be, if there was an x in here, like if I put an x here, then you could solve for x. But since there's no x, it's just 7 equals 42, you know that can't be true. So that's when you get the no solution. Make sure you understand this. You will see this again and again and again. So guessing is not going to help you guys. Okay? I would rather take extra time to teach you something you didn't already learn than you guess. Seriously. I'm not going to be mad that you didn't know it. I'm going to be mad that you guessed. Make sense? All right. Write your key ideas and your vocab words. I'll pause for just a moment. Okay, so we're learning about congruent figures. Does anybody know what the word congruent means? Aaron?
Oh, I know. Never mind.
Josh? Yeah, the same. It's like saying they're equal to each other. It's just a fancy word to say they're the same. A rigid motion. Okay, we've been learning about transformations. We've learned about translation, which is just sliding across or up or down. We've learned about rotation, your favorite. We've learned about, what's the other one? Reflection. Okay, a rigid motion is a transformation that preserves the length and angle measure. All three of the things we've already learned are considered rigid motions. Okay, so the shape of the item doesn't change its shape, it just moves around. We're going to do things that change the shape here pretty soon. Two figures are considered congruent figures when one can be obtained from the other by a sequence of those rigid motions. You know how Monday's assignment said, give me how this rotated, and you said it rotated 90 degrees and then it reflected. So those are two ways it translated. Nope. Transformed. That's the better word. Congruent figures are the same size and same shape. Angles with the same measure are called congruent angles. And then sides with the same measure are called congruent sides. So if you look at this diagram, you can see angle AB is congruent to DE. So see how it's colored red? Sorry, side length, not angle. Side length BC is congruent to EF, because the same color. AC is congruent to DF. You see that? And this is how they've labeled it. AC, this little equal sign with the squiggly mark on top, that's the sign for congruent. You need to know that. If you don't know that, put it in your journal. So this is telling me segment AB is congruent to segment DE. This is telling me segment BC is congruent to EF. And in mathematical terms, that just means they equal each other. So if BC is equal to EF, and I know BC is 6, then EF is 6. That's all you need to know from that. The measurements will be the same. Same with the angles. You see down here, we have angle A is congruent to angle D. See how it's got 3 lines? It's congruent to D with 3 lines. That's how you mark it. So whatever angle measure this is, if they said this angle measure is 37, then I could tell you that angle D is 37. Does that make sense? So then B is congruent to E. See how it's just got one line? So if E was 67 degrees, then B would be 67 degrees. And then angle C and angle F are also congruent. Okay, so these are just the rules you can use to solve for things when you put the numbers in. Questions? Okay, let's do the example. So we're going to identify any congruent figures in the coordinate plane. Coordinate plane just means graph. You guys know that by now, right? Okay, so what does congruent mean? They're the same. So we have to find shapes that are the same size, length. They can be twisted around and upside down, but nothing should have changed size-wise, right? So looking here, are there any off the top of your head that look like they might be congruent? Kerwin? Down here?
Yes, down and
This is quadrant 4.
yes.
You guys know your quadrants?
Yes.
It looks like a C. 1, 2, 3, 4. Start up here, like Carrie. Quadrant.
That's one thing that we actually learned.
So quadrant 4,
Yes, and quadrant 2.
quadrant 2. So he's saying JLK is congruent to QPR.
No, never mind. That's not.
He said no. Anybody else? Camila?
Quadrant 1 and quadrant 4.
These two, yes. They would just be considered a reflection. So definitely these two are going to be congruent. Any other two? Josh?
Quadrant 2 and quadrant
Yeah, these little guys. This little triangle and this little triangle. That's just a translation. Okay? So you see here, FDE, triangle FDE, and this is how you write it down. See they draw a little triangle here? Triangle DEF is congruent to MNP. See the red and the green triangle? The biggest key to remember is, oh look, it moves, is you have to write them in the same order when you write it. So if I start with the vertice D, I have to start with the vertice M when I write them. So DEF, triangle DEF, and MNP are congruent. That's hard to say, MNP. All right, so that's the little triangles. Now let's look at the two big ones y'all discovered. We have triangle ABC. So then I would also go JKL. And their reflections, so they are congruent. Now, is QPR congruent to anything? No. It doesn't match anything. I'll give you a hint. It's probably a dilation, which we're not doing today, hopefully. All right, any questions on finding congruent figures and how to write them as equal to each other? All right, do your try-its. Just one for the moment.
So we don't have to write anything for the example?
Good question. I would like you to write the wordings. The triangle DEF and triangle DMNP are congruent. Just that part. I'll open it back up. So I just want in your journal, put example 1, and then put triangle DEF and NMP are congruent. Or you can do even the congruent sign. Does that make sense? So triangle DEF, and then put the equals with the squiggly over it to triangle MNP, and then do it again for the second one.
That's what you would do to show that they're...
That's how you show that they're congruent, yeah. They want you to start using the word congruent, not equal. Congruent. When you hear congruent, that's meaning you're talking about lengths and sizes and shapes that you don't actually know the numbers of. You're talking about letters. Okay? All right, I'll give you a few minutes to do the try it. All right, the red figure is congruent to the blue figure, so we already know it's true. That's what I got to read. Describe a sequence of rigid motions between the figure. All right, so looking at this figure, how do I get it to be where the blue figure is? Take a guess.
Rotation.
And then?
Rotation and then reflection across the line.
Rotate. And
There's always more than one.
Rotate and then translate.
So which way are we rotating?
To
Clockwise or counterclockwise? So you're saying rotate to quadrant 4 and then reflect it.
Yes.
Yes, ma'am.
Let's see what they think. Oh, y'all are so good. Rotate. And actually, it's not a reflection, because look, once you rotate, what does it look like? It's in the right shape. So it's called a translation. So you're going to rotate, translate up. Very good. Y'all are awesome. Okay, if this is hard for you to visualize in your head, I highly recommend you graph this, you sketch this. Question? I would do the graph. Oh, for now? Example 2, you would say it is a rotation 90 degrees counterclockwise, and you can put CCW. And then translation, how far did it translate? Do you guys remember? How many? It went up, it translated 1, 2. Translated plus 2.
Yes.
So translate it plus 2.
Or 4. 4 units.
Yeah.
1, 2, 3.
Translated up 4 units. Because I would have to go from this point to this point.
Oh yeah.
Silly me. So it translated 4 units up. Any questions? All right, go do the next try it. All right, so here's our last example. Example 3. You can use the buttons shown at the left, these buttons, to transform objects in a computer program. You can rotate objects 90 degrees, that's this one, or in this one. And you can reflect objects in a horizontal or vertical line. How can you transform the emoji shown below? So look at this circle Which direction is this rotating?
Clockwise.
Clockwise. Which one is this one?
Counter.
Okay. This is reflecting across the...
The
Y.
This is reflecting across the X. Okay, good. So if I have this figure, which way would you go first, Josh?
Reflect it to like or like what yeah.
So he wants to reflect it, so it's going to go bloop over here. And then what?
And
Oh, yeah.
would rotate it counterclockwise.
Yes.
And then
Okay, so they rotated it first. And you see how the tongue is up high? So the tongue's up here. Okay? And then they reflected across the horizontal. So we rotated it counterclockwise and then reflected. He just reflected and then rotated. It doesn't matter. Do we follow?
yes, ma'am.
Questions?
No, ma'am.
All right. That's it. He wants to know what to write down in the journal.
Yes.
So you're going to say rotated 90 degrees counterclockwise and then reflect across the X. Good?
Yes.
All right, I'm closing.
Reflected off the edge.
Oh, across the X.
Okay.
Like if this emoji was actually in a grid, you would reflect across the X line to do that. All right, so then you have self-assessment 6 through 7 and you're done.
Yes.
All right, any last minute questions, 8th grade?
No, ma'am.
All right, 2 more problems, not too bad.